All right, today is lesson 8.2, day 1, but actually I'm starting with a review problem from yesterday from section 8.1. And in that section, there was this question about decibels. And I wanted to talk you through it and see if you understood how this one worked. All right, first off, it says compute 10 to the negative, or L of 10 to the negative 6. That implies 10 to the negative 6 is the I, because see how they got L of I set up here? That implies they're saying that I is 10 to the negative 6. So I put the 10 to the negative 6 right here, and then you subtract powers in this situation. What is negative 6 minus negative 12? 10 to the positive 6. So this is 10 log, and notice, remember me saying that if it ever doesn't have a base, then it's all about that base? Okay, yes, I know. Megan would be proud right now. So base 10 of 10 to the 6th, because of the negative 6 minus negative 12. And why is that so cool? Because this whole thing equals 6. Because if the bases are the same, the answer's already there. And it's 6 times the 10 then gives you 60. Raise your hand if you had a 60 for that. Okay, good. That's the sound intensity level. As opposed to the actual intensity, which went here, what you just found was the level. It's level 60. Okay. Now, this next part is where they're going to say you get hearing damage if you get 115 decibels or more. I really think that the day will come pretty soon when your iPhones and whatever other brand, Samsung Galaxies or whatever, are going to be forced to tell you what decibel it's putting out if you're playing it through headphones. Because I bet you none of you have an idea of how many decibels are coming out in your ears at any given moment. You know what I'm saying? You have your headphones on, you're looking at your sound, and you know the little meter is at, like, I don't know, 3/4 of the way, but you have no clue how many decibels that is. What if you knew you were playing stuff at 120 decibels and you knew that 115 is the moment where damage starts to occur? Do you get how you might not quite decide to rock out that hard if you knew you were damaging your ears? But I think since we don't know, you just kind of like, well, I'll just go, and if it hurts, I'll stop. Here's the key. In this problem, it tells you the pain threshold of pain, which basically means is where it hurts, is at 140. And if you're at 115, it doesn't hurt, and yet it's causing damage. You get what I'm saying? So most people assume if it doesn't hurt, I'm not damaging my ears. If it plays so loud that it hurts, then it's for sure causing damage, because the damage level happens before it hurts. All right. So anyway, in the old days, a lot of people were in the Army. Like if you go back, if you put you back in time, I can't remember exactly how many years, but a number of years, a lot of you guys would have been going right into the Army when you came out of high school, because you were drafted. You didn't have a choice. And you go in the Army, and there was lots of really loud noises, because if you're standing on a ship and they're firing something, oh my gosh, really, really loud. Do you get how the people in the Army were kind of like, they're manly men who didn't want to look weak? Do you get how they commonly would not wear ear protection because they felt like it made them look weak? Like, oh, you're a wuss, you're wearing those earplugs. Well, the wusses that wear the earplugs can still hear now. And the guys who were the big tough guys and were like, I can handle it, now they can't hear. Okay, so you pay a price for that someday. Now, you guys don't have to worry about war right now, thankfully, but a lot of you guys are exposing yourself to heavy duty volume by putting your headphones on and putting them on too loud. And that just means that someday you're going to have to wear hearing aids where your friends that were a little smarter about it won't. And their only hearing aids, as you can imagine, wouldn't be super fun to wear. All right, and you still don't hear it near as well as a person whose hearing just isn't damaged. So, moral of the story, try to avoid damaging your ears, because people, I think that it only hurts, if it hurts, then you have to worry about it. It's actually before that. It's still too loud right before it hurts. Okay, so anyway, the 115 is where you can start getting hearing damage with short-term exposure at 115. So where's the 115 go? Is that here? Yeah. So how do I solve this thing then? This is a really common place to get stuck, and I know some people got stuck right here. Like, how am I supposed to get I? Well, here's the thing that I want to remind you of. Do you remember me saying that the most important thing on logs was to be able to rewrite them back and forth from logs to exponents, exponents to logs? This is one of those moments where you can't solve it unless you rewrite this as not a log. It's already a log. Get it out of log form. So the first thing you have to do is get the clump alone. Remember that little saying? Get that clump alone by getting the 10 off of there. So hopefully you divide it by 10. How many of you knew you should divide by 10? Awesome. And maybe some of you knew that, but you didn't know what to do after that. Well, if 115 is divided by 10, it's really 11.5, right? Equals log base 10. Notice I'm putting in the base because that's important. Of I over 10 to the negative 12. Rewrite this to the this is equal to that. So it goes 10 to the power of 11.5 is equal to I over 10 to the negative 12. See what just happened there? That was a rewrite. How many of you caught that and you figured that out yourself? Okay, and that's only half the class. So the rest of you guys, note, when you're stuck in a tough log problem, think about a rewrite. All right, now I've got to get this I alone. It's really close. I just got to times by 10 to the negative 12. Timesing by 10 to the negative 12. Times 10 to the negative 12. Cancels, cancels. I's alone. There's my answer. If I can simplify it. Do you know how to do it when you have something with two powers like that? What do you do to the powers in that situation? Add them. So in this case, what is 11.5 plus negative 12? It's negative 0.5. Do you know what negative 0.5 means? Well, first of all, just the 0.5. Ignore the negative for a second. What does 10 to the 0.5 mean? Square root. That's really important. Because do you get if I throw a square root into a problem today, these are all about powers and stuff. You've got to know what power that is. Square root is to the power of a half. So when this was like this, I know a lot of you just quit right there. It's okay if you quit right there, but you need to understand that 0.5 is 1/2. That means 10 to the 1/2. That means square root of 10. So what does the negative power mean? It means 1 over that. So the final answer is I is 1 over the square root of 10. Now I get you might not have gone that extra step, but do you get that 0.5 means 1/2 power and negative means 1 over that? Negative powers. Okay. All right. So the reason I want to go back and do this was twofold. Number one, to show you didn't need a calculator to do this really hard word problem. Okay. Number two is to remind you about how when you get stuck in a really hard problem, rewrite is often the answer. Number three is to talk about your hearing because, again, it's something precious that you can't just fix. Even with your eyes, if your eyes go bad, you can get LASIK surgery and just like fix it and not have to worry about it. I can't say that for everybody, but a lot of times LASIK fixes eyes. We don't have anything for ears yet. You still got to stick these things in your ears and hope that they amplify the sound. We can't fix ears. Maybe by the time you're my age, they can just fix ears, but they can't now. So be careful with them. All right. So this one is another example. We're not going to do it right now, but it would be, let's say that you day before the test, you're looking at one more problem that you could do for practice. That's one more word problem we're not going to do right now, but it'll be good for practice. So it involves lots of powers, and that's why it fits into this, because powers and exponents go with logs. All right, let's talk about what we learned yesterday, and I will now segue into the new material. So if you can find, I know I said I was going to grade this homework. I realized since today's a math day, I just don't have time, but we will grade it tomorrow, guaranteed. So if you did these last two homework assignments really thoroughly, you'll be rewarded for that, but not till tomorrow. All right, so if you could find the new lesson for today, I'll be able to get through it nicely if we start that right away here. Okay, so this is about log properties that we learned yesterday. And I want to just kind of like review a little bit of yesterday. Do you remember seeing this log base 2 of xy and how they broke it into two logs? Would you write what you think the answer to that is? I know you're not an expert on this yet. You just learned it yesterday a little bit. But that's where we get you from barely knowing it yesterday to awesome at it by the end of today. Okay, so this one was, it breaks into two logs, log base 2 of x plus log base 2 of y. How would it have been different if this had not been a multiply, but instead had been an x divided by y? It'd be a very similar answer. Yes, sir. Just be subtract. I would expand to that. Okay. Next thing, do you remember when there's a power in front, or sorry, not in front, when there's a power on the argument, like 2 squared, you got a little 2 up there, that power can drop down in front like this and say, become that. Now I want to make sure you understand why that is again. So I'm going to give you a new one here. Let's say log base 2 of 9. Would you just expand that out, kind of like before? We just did expanding 1 minute ago. Expand this. Because you know 9 is something times something. So you can expand it. So I'm saying log base 2 of 3 times 3. Expand it. I think you already knew that, but some of you didn't. Do you get that could be written as log base 2 of 3 plus log base 2 of 3? Now, one more thing. When we say to expand things, the directions are always going to be expand and simplify. This is expanded, but it's not simplified yet. Because if you have 2 of the exact same thing, like 2 x's, you shouldn't say x plus x, you should say 2x, right? So 2 log base 2 of 3. What could you have done way earlier in the problem to get to the same answer a lot faster? Yes, sir. Yeah, if you take this 9 and make it into log base 2 of 3 squared, then what right do you have? Move the 2 in front of the log, and you'd have had the same answer as we ended up with all of this work finally getting to. Okay? So that's called the power rule. All right, so here's how the power rule intersects with the expanding thing. What if you have log 2 log x, y? Actually, let's do it this way. I'll still keep it expanding. We're going to condense in a moment, but there. Let's say it's 2. That's a little power on the y. Well, you can still split them up, but you can expand it even further in this case. So try splitting this up, expand it. Notice I didn't use a base. Whew, scary. Okay. Something that shouldn't stop you. Try expanding that one, please. Everybody gets this part. Log base 10. I'm going to write it. You don't have to. Of x plus log base 10 of y squared. But that's not expanded all the way. What do you got to do? Take the put and put it in front. Good. This 2 right here is not here anymore. We're going to put it there. That's considered expanded form. All right. Now, how about if it's even more intense? Nope, wait. There. Expand it all the way. Work on that, work on this. Expand this all the way. Mr. N, Tell me how to expand it. Start anyway.
2 log.
It's a little too much. Just start with log base 2. I know where you're going, but I don't want to jump all the way to the right answer. But
I did x over 2, and it would be x squared.
Okay.
Plus y.
This is an interesting approach, but I don't think it's going to work for you. I know that's not your final answer, but even breaking it up like that means, well, actually, it might work. Let me let you finish and see how you do it. Because normally, right here, I would have made this into a subtract right away. I would have done that part first. Remember how I say always get rid of fractions when you can? And so we would have got rid of that by making that into a subtract log base 2 of 2. But maybe your way is going to still work at the end. Okay, fine. So I'll do it the way that I suggested, which was log base 2 of x squared y minus log base 2 of 2. And then what's special about log base 2 of 2? That goes 1. Okay, good. So then this whole part can just simplify down to minus 1. And now I just have to finish this part, which is log base 2 of x squared plus log base 2 of y, and then I still have my minus 1. Done? Oh, no, I have to take off 5% because the kid didn't finish. One last thing they forgot. That needed to go down here. Now I've expanded it all the way. Now I should look and see if I can simplify anything. Like if this happened to be a log base y of y or something, that could happen. I just need to make sure this is all simplified, and it is. So there we go. It's expanded all the way. Yes? Okay. All right. So that's expanding. Of course, what's the opposite of expanding something? Contracting, or in this case, we call it condensing. So that's where you start with one that's like the answer to one of those other ones. It's all expanded all the way out. And you can condense that all down into one log. Log base this of that. Try it without any help from me. I bet you can do it. Sort of like, here's the answer. What was the question? It's kind of like you opened a box at Christmas. You assembled the toy. It's all like done. And then you realize, oh, I don't like it. I'm going to return it. You got to put it all back together, make it all fit back into the box. Condense it down and fitting into the box. How many of you remembered to pack up the 3 and put it up there, and this 3 and put it up there? How many of you remembered that? Good. Then I got to put them together into one log, and of course it's base 2. I made your life simple by always having it be the same base. And then I can put them together and say x to the 3rd, y to the 3rd. Or it could even go a little bit further, although I would not give extra credit for this or anything. But if you had said both of them to the 3rd like that, that would have been okay. All right, that's not like it's really better. It's just an option. Okay, how about this one? Condense. Yes, I went there with the square root. Sorry. Isn't this just log base 2 of square root of x times y? Oh, that's close. Can't leave square roots in your answer. Yes. Yes. Gotcha. But, for instance, isn't this the same thing as that? And one of them's righter than the other. I know. English teachers across the world just cringed. You're right. So you're not allowed, you learned a while ago, I hope, that you're not allowed to leave negative exponents in your answers, and thus you must leave them positive. Same idea. We want you, and I just am trying to reinforce this for your own good, argue with me all you want, but if you have a square root, you need to know that that means power of 1/2. Okay, so use that. Especially because, do you get, if I had to rewrite a problem that was, let's say we go like this. And I had to rewrite that as a log, do you get how you'd have to know that x to the square root is like to the 1/2 power, so that I can get x to the 3rd to the 1/2, or x to the 1/2 to the 3rd, either way it works. Do you get then I could rewrite this as a log? Try rewriting that as a log now. That's a log. Log base something something. So know that square root means to the 1/2 power. All right. So the final thing I want to do with you is where you take a really complicated one that's all expanded and you condense it down. Because I think the hardest ones are when they start really big expanded polynomials or expanded logs. Yes, I'm aware that this adds extra challenge, but I think you can handle it. I want you to condense this into one log. 12 minutes left. Condense this down to one log. Christmas present has been unpacked. You have to pack it back up and fit it back in that one tiny little box. So this goes up here, and ooh, what do I do with that? Well, it becomes log base 5 of x to the, what would you do? What were you doing before? Were you adding it to the power, or were you multiplying it by the power? Let's say it had been simpler. Let's say it was just that. When you stick this up here, were you adding it to the power that was already there? No. You must have been multiplying. So you'd multiply. This would be to the 6th. Do you get what I'm saying there? Do you get, when I try to move this up, I can't just set it, there was a 1 there before, so you weren't adding it to that power. You were multiplying it by that power. So 3 times 2 makes 6. And then minus means divide has to be involved. Divided by 125, ooh, also known, you don't have to do this. You could have said 125, but you could also have said 5 to the 3rd. Get what I'm doing there? Then that part could even be simplified more, but I would have accepted that as a good enough answer. Okay. I think you're ready. Let's look at the homework. Find this one. This has got that square root thing in it, but wait a minute. Look at number 11. That's not a square root, is it? What is that? What kind of root is that? 4th root. That means to the power of 1/4. All right, that's important. Okay, so I'm going to have you skip this one and this one. and that one on this page. Nope, 7, 10, and 12. I want you to do 11 because it's got that root in it. All right, those are all expand problems. I get you don't have much room here to actually show all the work and stuff. If you need to do it on a separate sheet, you got that split screen optionally, some of you do. So, or just take a piece of paper and do them, because sometimes these take a lot of room, but it's up to you. All right, this page, more room to condense them, which is actually kind of silly. You should add more room to expand them. Condensing you can do in a really small space. But there's so few of these, I think we should do all of them. They don't take very long if you know what you're doing. Notice there's a 1/3 out in front. When you put that up on the Z, you'll have a power of 1/3. But do you get that that means third root? Okay. But when you leave your answers, I'd like you to leave them with a fraction power, not a root. Okay, on to this page. This is just use a calculator too. And so since it's that easy, you're going to grab a calculator. And do you remember how to type that into your calculator? What? Log what? Log 12 over log 3. And you don't have to even write that all out. You just have to, oh wait, it does say use the appropriate change of base formula. So yeah, I should write that out. And then I should say the answer that the calculator gives me. Okay? All right, we don't need to do many of those. Cross off 35, 36, 38, and 39. We can dump all of those. Okay, I think this is really good for you because this and this are very closely related, and I'd like you to see what they actually look like. And since you got your calculator out on this page, feel free to use the calculator to graph them. And when you see the results, I think you'll learn something. I think I'm okay with you skipping 42. I know I'm okay with that. And skipping 44. And that's it. The next page says today again. That means this is another one of those combo 2 days in 1 assignments. So we'll be using this same file tomorrow. All right, I think that's a very reasonable amount of homework. And I'm giving you some time to work on it right now. That's all I got for you for today.